Hello, guys. This is for class on Wednesday, the 21st, and also Tuesday, Thursday class for April 22nd. So in this lesson, we are going to do all of 7.4 and part of 7.5. And then next week, Monday and Tuesday, we're going to finish 7.5, complete 7.6, and then guess what? That's it. No more new lessons. Yay! All right, so tonight we're going to talk about the properties of logarithms. So, you know how when we were learning our exponent rules and I said, x to the 5th power divided by x to the 1st power, you're actually going to subtract those exponents and we get x to the 4th power. Well, that's kind of like, properties are kind of like that, things that have been proven to be true. So it's telling you that these two expressions are equivalent. So if you have log base A of x plus log base A of y, first of all, those logs have to match each other exactly. And the rule is when you have a number plus a log, plus another number, basically what you're going to do is multiply those numbers together and they're equivalent. Same thing is true with this one. Log base A of x minus log base A of y is the same thing as log base A of x divided by y. So division goes with subtraction, addition goes with multiplication. And our third property tells us how we get to take an exponent, bring it up to the front as a whole number or as a factor of the log. All right, the opposite is true. If we have a number in front of the log being multiplied by the log, we can move it back and it becomes a little exponent. So we're going to use all of those properties. Okay, so your first two Hawks homework problems look very similar to these. So what you're going to do on these is you're going to, first of all, find the greatest common factor of 48 and 80. So the greatest common factor of those two numbers is 16. So we're going to write the log base 4 of 16 times 48x divided by 16x is 3x. 80y divided by 16 is 5y. All right, let's concentrate on log base 4 of 16. What does that equal? Well, remember last week we started doing logs. We said you take that base, raise it to this exponent, set it equal to 16. What would that number be right there? 4 raised to what power 16? Well, the answer is 2. So log base 4 of 16 is 2. So that's what that quantity is. And then since this is being multiplied, we're using addition, just like those properties told us. So 2 plus what? 2 plus log base 4 of 3x plus 5. And that is our answer. So on Hogs, it's going to give you a box here. You have to plug in a box for both coefficients. And I think maybe the base of the log. I don't remember. But hopefully when you get to those problems, you'll go, oh yeah, we already did these. So hopefully this will help you. Let's do one more just to double check. First step, find the least common, or excuse me, the greatest common factor of 20 and 12 is 4. So we're going to do log base 4 of 4 times 20x divided by 4 is 5x. 12y divided by 4 is 3y. And then once again, what is log base 4 of 4? 4 raised to what power equals 4? So the answer is 1. Then I see multiplication, so we're going to say plus log base 4 of 5x plus 3y. And there is our answer. So you'll have at least 2 of those when you certify for Hawks. All right, so let's see what's going on here. So we have the ln, the ln, and the ln. Those all have to match. The logs or the ln's have to match exactly for you to apply those properties. So since I see addition, I know that we're going to rewrite it with multiplication. And since I see a subtraction problem, that means we're also going to use division according to the properties. So we're going to write the ln of 15. Now, one of the properties said you can take a factor, one of the numbers in front, you can turn it into an exponent at the end. So 15 times x raised to the power of 2, there's that number, divided by, because there's subtraction, we have a big number, a factor, and we're going to throw it over here with the y, and we put y to the 6th power. And guess what? We're done. All right, now these we're going to do the opposite. We're going to take the ones that have been condensed and we're going to expand it. On the last page, we took the ones that were expanded and we condensed it. Now we're doing the opposite. All right, so let's look at the first one. So the first thing I notice is this is log base 10. So remember, when there's not a base, it's automatically base 10. You either get to write it or you don't have to. Either is fine, only with the base of 10. And then I see 5 times A times B to the 4th. So since I see multiplication, to expand it, that means we're going to use addition. So what would that look like? We're going to do log base 10 of 5 plus, because of multiplication, log base 10 of A plus another multiplication. And now we're going to bring that 4 and we're going to put it all the way in front, times, or excuse me, plus 4 times log base 10 of B. And that's it. We have expanded that expression. All right, now we're going to do the second one. I see 64 times x times the square root of y. So I know we're going to be using addition again. So we're going to start with log base 4 of 64 plus, because of that multiplication, there's a 3 as an exponent. So we're going to bring it all the way in the front. Log base 4 of x. And then remember how, let's go up here. So remember how we talked about our exponent rules? What's the same thing as writing the square root of y as an exponent? Remember, you can write y to the 1/2 power. So we're going to say plus log base 4 of y to the 1/2 power. Now there's a couple of things we can do. So let's look at just this right here. So if we take that base of 4, what exponent would we need to equal 64? What would be the exponent of 3? So log base 4 of 64 is equal to 3. That simplifies to 3 plus 3 times log base 4 of x plus, here's our exponent. We're going to bring it all the way out here in the front, according to those properties, 1/2 times log base 4 of y. And now that expression is simplified. Okay? All right, just to clean up this screen, I'm going to delete everything, so you can always rewind if you need to. All right, now the last one looks a little scary, but let's clean it up a little bit. Let's rewrite the cubed root. How do we write the cubed root of a number as an exponent? Well, remember, we would write it x to the 1/3 power. We learned that the first section of this unit. So let's rewrite it first, make it a little less intimidating. Log base a of xy squared divided by z to the 4th. All right, now to expand it, remember, when we see multiplication, we're going to write addition. When we see division, we're going to write subtraction, right? So let's expand it. So we have log base a of x plus, here's an exponent, we're going to bring it in the front, 2 times log base a of y, and I see division, so I'm going to write minus, an exponent would come to the front, so we're going to write minus 4 log base a of z. All right, I'm going to double check my notes. I don't want to mess you guys up trying to find it. And the only thing I forgot is forgot is when I rewrote it, even though I wrote it right here, I forgot to write the exponent of 1/3. Did you catch that? I dropped that whole part. So what I should have done, the very, very, very first thing is pull that up to the very front. And now it's exactly right. There we go. So I talked about it and then I dropped it. So my bad. But now it's exactly right, because now that 1/3 times all of this, that was where that cubed root, the radical, that's how we got to drop it. All right. Okay, here we go. All right, now this one, we're going to expand this logarithm, which means when we see addition, we're going to use multiplication. When we see subtraction, we're going to use division, okay? So as long as your logs match or your LNs match, and they do, so we're going to do the LN of what? So this is 16x. Now this 16 is not in the front. It's not right here, so we can't make it an exponent. We're just going to have to keep it together. 16x times, because of this plus symbol, y. And the only reason I'm flipping these is because I usually try to put my variables in alphabetical order. So I'm going to write 16xy. And guess what? That's all there is to that one. That was pretty easy. We just had to throw those things together. When we see addition, we know that we have to use subtraction. Or let me say it again. When we see addition, that means we're going to show it in multiplication. Okay. All right. I'm just finding my place in my notes. Okay. So now on this one, very similar. Our logs match log base 10. I see subtraction, which means all we're doing is dividing. So we're going to write log base what? Oh, base 10, because there's not one indicated. And so I'm going to have x divided by, because of that subtraction sign, and this stays together, 6y, and that is simplified. It's, yeah, that's it. That's all we can do. Yep, we're done. All right, so here we're going to condense these. So on the previous page, we did the opposite. We took one, well, we condensed these as well, right? Let's see, use the properties of logarithms to expand. So now we're doing the opposite. All right, so here we go. I see a minus. So when we condense it, we're going to use multiplication. If I see a big number in the front, that means it's going to become an exponent. And so let's get started. All right, so let's do log base 3 of, we're going to take that 2, we're going to make it an exponent for this whole thing, x over 3 squared, right? Now, if you had minus a number, we're going to leave it as a minus, but really we're going to almost think of this, instead of minus, we're going to think of this as plus a negative 1. Plus a negative 1 times log of 3, okay? So if there was a coefficient here, we're going to leave it as minus, but when we see minus and there's no number, we're going to think of it as actually this number is being multiplied by negative 1, so we're going to think about it as plus negative 1 times log base 3. So really, we're going to rewrite plus. And that negative 1 is going to go to the back and become an exponent. So we're going to write plus log base 3 of 1 over y to the negative first exponent because of this right here. Okay. All right. So what can we do with this now? Well, we can square x over 3 squared. So what is x times x? X squared. And what is 3 squared? Remember, you multiply every exponent by 2. So 3 squared is 9. Plus, now what does a negative exponent do to everything in here? Well, it's going to flip it. So we're going to write plus log base 3 of y. All right, so finally we get to actually condense it. When we see addition, we're actually going to multiply. So we're going to multiply, if we multiply straight across x squared times y, log base 3, x squared times y is x squared y over 9. And now there's nothing else we can do, and that is our final answer. I'm about to erase it all. All right, so let's try the next one. I'm just going to double check my notes, make sure I got everything. Yes. Yep, that's exactly what I got on the last one. All right, now this one looks like there's a lot going on here. So first of all, we check, make sure these match. They all match exactly, right? So we're going to condense. When I see subtraction, we're dividing. When I see plus, we are multiplying. So we're going to write the ln of x squared, and then it says divided by, so I'm going to write minus. This gets thrown over here with the y. So I'm going to write y to the 1/2. It's not negative 1/2. The negative just means we divided, right? And then I see plus ln to a 2, okay? So now when we see addition, we're going to multiply. We're going to multiply straight across. So x squared times 2 is 2x squared. And in our denominator, we have y to the 1/2. And we are absolutely allowed to leave it that way. We know that y to the 1/2 is the same thing as a square root of y. So if you guys ended up writing this, that's okay too. So these are equivalent and they're both absolutely okay. All right, so that was the second problem. All right, let's go to the third problem. All right, so I have a plus symbol, which means we're going to multiply. I see a factor in the front, which means we're going to throw to the back, right? So the log base b of 5 times what? Well, if we throw this 2 over here, we actually have to multiply the 2 times -1. Well, 2 times -1 is -2. So a number to a negative exponent makes that jump down to the bottom. Okay, so if we multiply 5 times 1 over x squared, well, let me write that first. So we're going to write plus log base b of 1 over x squared. And now that means actually we're going to multiply. So we're going to write log base b, 5 times 1 is 5 over x squared. And now there's nothing else for us to do. And that is the final answer. Okie dokie. All right, let me get rid of that. All right, so guys, when you have a natural E, if you think of this as, well, let's get our exponent down to the front, and I can do that if I find the ln of E. Well, anytime you see the ln of E, that's always equal to 1. So basically the ln of E, they cancel each other out. And we get to drop the exponent as a whole number or a whole expression. So basically that just gets dropped because we found the ln of E, which equals 1. So we get to bring down as whole numbers 10 minus 8 ln of x plus the ln of y. All right, 10 is a whole number, so it's going to stay a whole number. Now, what are we going to do with this plus symbol? Well, we're going to multiply. So when you have a whole number in front of an ln or a log, you get to make it an exponent. So we're going to say 10 minus the ln of x to the 8th times, because of that plus, y. And then that is the answer right there. That's the final answer. All right, now these two, I like these two problems because our calculators will do this for us. So you are in your calculator, you are literally going to type this in exactly like you see it. You're going to hit the LN button, and then your calculator brings up parentheses. Then you hit your log button. Once again, it brings up another set of parentheses, and you just hit 3. You can end your parentheses or not, and it gives you a quantity. And if you read the directions, it tells you how far to round. So it says round to 2 decimal places. So my calculator tells me negative 0.739. If it says 2 decimal places, we have to go out 3 decimal places, and that tells us what to do with that number in the hundredths place. So my answer is negative 0.74. And that is my final answer. Now, those of you with the Casio, it allows you to change the base of the log. If you don't have this calculator or another calculator that allows you to change the base, you'll have to do it a different way. So the Casio has a button that looks like log, and then it has a box down here and right there. That means you get to type this in exactly like you see it in the Casio. Everybody else, we have to, kind of change it so that we can still use our calculators. So basically, if you don't have the Casio, if you just have a log base 10, or your calculator just says log and there's no box down here, then what you're going to do is this format. You're going to do log of the big number, 0.326, divided by log of the base. And you always have to do that exact format, okay? It's always, the numerator is always log of the big number divided by the log of the base. So in my calculator, I'm bringing up my fraction button. I'm typing in log. I'm typing in 0.326 over log of fraction 1/7. And my calculator tells me the answer is, I'm sorry, digging for my pen, it is 0.576. So that 6 turns my 7 into an 8. And that is the answer I would type in either Hawks or My Open Math, either one. All right, let me grab my notes again. I don't want to mess you up. All right, now this one, it says we're going to use the properties of logarithms. So when I see subtraction, I am going to use division, right? These match. So I can say the ln of x plus 1 minus means, whoops, I didn't mean to do that, parentheses, divided by x equals 5. All right, so on this one, I'm actually going to, in order to get rid of the ln, I'm going to, if I find the ln of both sides, or you know what, if it doesn't have a base right here, that means it's the ln of the natural e. So I'm going to find the natural e using the exponent of 5. So once I think of this as the ln of e, so the ln of e is 1. So if I find the ln of e, that basically gets canceled. And all it means on this side is that I am going to use my calculator and figure out what is the natural e to the 5th power. Okay, and I'm going to do that in my calculator eventually, but not right now. I'm going to wait because I want to end up with x on one side of the equal sign. Okay, well, here's a single x. In order to free up what's in the numerator, I'm going to do the opposite of divided by x. So I'm going to multiply both sides by x, which allows me to cancel that one out. So I have x plus 1 is equal to e to the 5th x. Now this is a whole term. This is a whole term. I do want to get that x by itself. So what I'm going to do is minus 1 from both sides. I'm going to subtract 1. So now I have x is equal to e to the 5th power x minus 1. Okay. Let's see. In order to get my, you know what I should have done? I should have, instead of, I should have subtracted. Let me see. Let me look at my notes for a second. What did I do? I multiplied both sides by x. Okay, now I do see what I did. All right, sorry guys. Let me erase a little bit. All right, so remember when I told you I could find out what e to the 5th power is with my calculator? Well, let's go ahead and do that. So in your calculator, we're going to do your second button. We're going to hit your LN button. It brings up an E, and then your exponent is flashing. So I'm going to type a 5, and it tells me e to the 5th power is, let me write this back. I haven't got rid of that x yet. E to the 5th power is 148.4132, basically. All right, sorry about that, guys. So now I do want to get rid of that divided by x by multiplying both sides by x. So now that's gone and that's gone. So up here, I'm going to write x plus 1 is equal to 148.4132x. I want to get my x's together. So I'm going to cancel out this positive x. I'm going to subtract 1x. Subtract 1x. So I get 1 is equal to 147.4132x. And then my last step is to get rid of times. X times this big number. I'm actually going to divide both sides of the equal sign. This goes away. I need 1 divided by 147.4132. And I'm going to throw that in my calculator. I'm going to say 1 divided by, and I'm going to recall that number I just typed in. And my answer is 0.00673. And it will usually tell you what to round it to. So this would probably be rounded to 0.00067 is what x is equal to. Yikes, that was ugly, you guys. That was ugly. But that's how you do it. I'm sorry, I forgot to do. I should have gone ahead and straight went to this on your calculator. I was trying to move on ahead before doing that. All right, so let's just get barely started on 7.5. This has been a lot so far, but you know, maybe in your college algebra class, you've already progressed farther than this, so I'm going to go just a little bit farther. All right, so they are just reminding you of those properties of logarithms. That's the first slide. All right, so let's look at a couple of these problems. So this is a long one, right? It says, solve the following logarithmic equation. Express your answer as either an exact expression or a decimal approximation rounded to 4 decimal places. If there's no solution, indicate no solution. All right, so what we're going to do is, since we see plus here, we're going to use multiplication. These match exactly log base 5, log of base 5. So we're going to write log base 5 of x plus 1 times x plus 3 is equal to 2. All right. Well, what does this look like? This is multiplying 2 binomials. So remember that we're going to FOIL them. X times x is x squared. X times 3 is 3x plus 1 times x is 1x. And then 1 times 3 is 3. When we simplify that, we get x squared plus 4x plus 3. So we're going to say log base 5 of x squared plus 4x plus 3 is equal to 2. So how do we rewrite this? Remember, we take that base 5, we say raised to the second power equals whatever our factor is. And in this case, it's x squared plus 4x plus 3. Well, 5 squared, we can figure out what that is, can't we? All right, and now since it's a quadratic, we want this equal to 0. So we're going to subtract 25 from both sides. So we end up with x squared plus 4x. 3 minus 25 is minus 22 equals 0. So then I think, okay, are there two numbers that multiply to give me negative 22 and add to give me 4? But the only factors of 22 are 1 and 22 and 2 and 11. There's no way to get a 4 from those combinations, which means we have to use the quadratic equation. So remember, the quadratic equation is negative b plus and minus the square root of b squared minus 4ac all over 2a. So the opposite of b is negative b plus and minus the square root of b squared minus 4 times 1 times negative 22, all divided by 2 times 1. All right, so I'm going to type in my calculator. 16 minus 4 times 1 times negative 22, and my answer is 104. So now I want to know what's the square root of 104, and my calculator tells me the square root of 104 is 2 square roots of 26. So we have negative 4 plus and minus 2 square roots of 26 over 2. All right, we can divide 2 by 2, 2 by 2, and negative 4 by 2 is 2. So we have negative 2 plus the square root of 26. And the other answer is negative 2 minus the square root of 26. Well, if you try to find the logarithm of 0 or a negative number, it's undefined. So I bet you one of these gives us a negative answer. So I'm going to type them in. Negative 2 plus the square root of 26 is equal to a positive number. It's positive 3.099. The other answer is negative 2 minus the square root of 26, and I get a negative number. So if you end up with a negative solution, you have to get rid of that because you're not allowed to find the logarithm of a number 0 or less. So the only answer is this, and it told us we can have an exact answer. So this is absolutely fine. If I need to put that in decimal form, my calculator will do that for me, and it'll be like 3.099. Okay? Whew, it's a lot of work. All right, I think one more and we're done, you guys. One more and we're done. All right, so this is similar to that one. So let's see what's going on with this one. So the first thing you want to realize is if you have the logarithm of this plus the logarithm of this is equal to the log base 9 plus log base 9. That means that basically if you have log base 9, log base 9, log base 9, if it's on the other side of the equal sign, guess what we get to do? We actually get, well, let's go ahead and condense it. Log base 9 of x minus 4 times, because we see addition, x plus 2 is equal to log base 9 of x plus 1. All right, what I was trying to say is if we see log base 9 of all of this is equal to log base 9 of this, that means we get to cancel out log base 9. That means that these two expressions are equal to each other. So x minus 4, so we get to get rid of log base 9 completely. Let's cancel it out. And we have this expression right here. This is equal to this. That's what this says right here, basically. That's what this said. So we're going to FOIL this side. So x squared, and then 2x minus 4x is negative 2x. Negative 4 times 2 is minus 8 equals x plus 1. Since it's a quadratic, we want it equal to 0, which means we're going to subtract x and 1 from both sides. So we have x squared minus 3x minus 9 is equal to 0. Is there any way we can get two numbers that multiply to give us negative 9 but add to give us negative 3? No, which means we have to use a quadratic formula. So we're going to do the opposite of b, plus and minus b squared minus 4 times 1 times negative 9 all over 2 times a. So in my calculator, I'm going to type in what's under the radical. So I'm going to type in 9 minus 4 times 1 times negative 9, and I get 45. So what's the square root of 45? Square root of 45 is 3 square roots of 5. So I have 3 plus and minus 3 square roots of 5 over 2. So if I type in fraction bar 3 plus 3 square roots of 5 over 2, I get a positive answer. But then I notice when I type in 3 minus 3 square roots of 5 over 2, I get a negative answer. You're not allowed to have the logarithm of a negative number. So my only answer is 3 plus 3 square roots of 5 over 2. Okie dokie. And that's the only answer, because the other one is no, what's it called? Invalid, or forgot the term, but you guys know what I'm talking about, I think. All right, you guys, well, we will finish up on Monday, and then you guys will prepare for Unit 4's test and your final exam. All right, guys, let me know if I can help you in any way, and I'll see you for class. Have a good night.